Hello students. In our previous lecture, I hope you could recollect we have studied about Hadoop, what exactly Hadoop is and how Hadoop frameworks helps us to store and process large amount of data, since nowadays we are talking and we are working basically on big data. So how Hadoop is using for storing and for accessing large amount of data. In our previous lecture we also took the example of cook and shelf. I hope you guys can easily recollect what was the example and how it is basically related with the Hadoop. We also saw distributed and parallel approach in our previous lecture, and but obvious, since we saw distributed and parallel approach, we also go through the map reduce concept. Now coming on to the Hadoop architecture. So in today's lecture we would be studying about Hadoop architecture, what is HDFS, what is name node, resource manager, all those concepts. So as you can see in the figure, Hadoop architecture basically consists of a master node and a slave node. Now this architecture basically consists of only one master node, whereas it may have more than 2, 3, 4, any number of slave nodes. It depends upon the structure created by the organization, by the platform in which you are working. Now master node will contain a name node and a resource manager, whereas a slave node will contain a data node, a node manager, and a map reduce. Now all these concepts gradually we will see one by one in detail. I hope the map reduce concept must be clear to you because it was already studied in our previous lecture. Coming on to the components of Hadoop, as we saw that the architecture of Hadoop consists of basically works on two main function, which is HDFS, Hadoop distributed file system, and second one is map reduce. We have already studied map reduce means it is basically processing the data which is present within HDFS. So map reduce works on the concept of distribution or parallel execution and then combining the data. So both the concept when combined creates a map reduce concept. What is HDFS? HDFS is Hadoop distributed file system, which is basically the function of HDFS is to take care of stored data and to manage those data in Hadoop cluster. Whenever we are working in a Hadoop cluster, one component or one device has to do this task of storing the data and managing the data. This task is done and managed by HDFS in Hadoop. So if we talk about the main function of HDFS, HDFS stands for Hadoop distributed file system, and it basically stores and manages the data in Hadoop cluster. Coming on to the main components of HDFS, the main components which comes under the category of HDFS is name node, data node, and secondary node. Master node is known as name node. Name node, the main node of the cluster, or the master node of the cluster is the name node, and data nodes are its subparts, or you can say child nodes. So what name node is doing, name node is basically maintaining and it manages the data nodes. All the data nodes it is having, you can see with this figure also. Master node we have, which is known as name node, and in its child it is having slave node, which refers to the data node. So the main function of the master node or the name node will be to manage the data node. If it is having 2 or 3 or multiple data nodes, that all those data nodes has to be managed by the name node. It basically contains all the data which are required by the data blocks, how much data it is being stored, how much data it is being accessed, at what time it is being accessed, all the details, where exactly the data is being stored, what is the size of the data, what is the type of the data, all those categories, all the details of the data is maintained by the name node on timely basis, and it is being updated by the name node also. Now data nodes basically stores the actual data. It serves read write request from the client. Whatever the read request is made by the client and whatever the write request is made to the client, all those requests, all the data which is required to fulfill but obvious read and write request, that has to be stored by the data node. So Name node and data node both are important for Hadoop cluster, and they both perform different activities, perform different roles in Hadoop cluster. Coming on to secondary name node, metadata is nothing but the information about the data. What exactly metadata means? It is nothing but it is showing you the information about some data. It displays or contains information about the data that took place across the Hadoop cluster. So whatever data is stored, that has to be managed across the Hadoop cluster, and metadata is giving the information about the same. This metadata is maintained by the Hadoop by using two files. Two files is used by the Hadoop for maintaining metadata, that is fsimage and edit log. These two files basically are very important to perform this role, that is to perform checkpointing. What is checkpointing? That we would see now. fsimage is the one file which is used by the Hadoop for maintaining the metadata, and edit log is the other one. fsimage will contain all the information or data across the Hadoop cluster ever since the name node was created. So what exactly checkpointing it is the process of combining two files, that is it makes copy of edit log and fsimage from name node and combine it to create fsimage final. So checkpointing, it is the process basically in which we are combining these two files, edit log and fsimage file, and we are creating a final fsimage file in which we would be inculcating all the functions which are performed by edit log and fsimage. Now why it is done? It is done by secondary name node so as to keep a copy of a data. For example, in case in any particular situation, if name node gets halted or name nodes get corrupted, then a secondary name node will be there to give all the data, to provide all the data. So this is the main task of checkpointing, which is done by secondary name node. I hope this point is clear to all. In our next lecture, we would again see with an example what is MapReduce and how it works with Hadoop. Thank you.